Hi everyone, this video is for section 7.3, simplifying by factoring, which is the second part of this lesson. We're going to actually dive right into a problem first, and then we're just going to go straight into some practice. So the problem that we're going to look at is going to be the square root of 18 times a times b squared. What we essentially want to do is we want to see what numbers we can break out of our square root prison. So again, remember that if we can't see it, this root must have an index of 2. So what I'm going to do is I'm going to work in chunks. First, I'm going to look at 18 and kind of ask myself, how can I break this down? So I'm going to take it down to its prime factors. And you can really start anywhere that you want. So for example, I might say, well, 18 can be represented by a 9 times 2. And I'm going to note that 2 is a prime number. I can't break it down into any other factors. 2 is as low as I can go. Unique factors, I should say. The 9, however, I can keep going into a 3 times 3, where 3 is also prime. So because of this, I can now look for pairs. I need two numbers that are identical to each other in order for them to escape the root. So here we have our pair of 3's. So we can write a 3 on the outside. And then I'll go ahead and I'll put my square root under here. The 2 does not have another 2 to pair with, so 2 is still stuck underneath the root. Very similar to our situation with a. A is technically raised to the first power, so that means that there's only one of the a, so I can't do anything else with it. B, however, we want to note b squared can be broken into b times b. So I have a pair, which means that I can send it outside. So my final answer would be 3b times the square root of 2a. And that's all that you're really expected to do in the second part of section 7.3. So the next screen we're going to move to will be some practice problems. So before I actually begin to do those solutions, I highly encourage you to pause the video and work on those practice problems on your own first, just in order to kind of see what's working for you, what's not, where are some challenges coming up, and then when you're ready, start to watch through the solutions and give yourself some good notes, and also some good questions that you can bring to me. Okay, here we go. So the first one we have here is we have a square root of 2x squared plus 8x plus 8. So what I'm noticing first off is that I have a trinomial, specifically a quadratic. And this is a quadratic because the largest exponent that I have here is a squared. So recall, and I'm going to do this in kind of red to let you know what we cannot do. We cannot break this into 2x squared plus the square root of 8x plus the square root of 8. That's not possible. We cannot break that square over each term. So this is not an option. What we can do, however, is I'm going to note that this is a square root. And what I kind of want to notice first off is that look at each coefficient. I have a 2, an 8, and an 8. In this particular case, they all have a factor of 2 in common. So I'm going to factor out that 2, and that's going to leave me with an x squared plus 4x plus 4. The next question that I should ask myself is, since I'm working with a quadratic, I wonder if I can go ahead and factor this down into a product of two binomials. And remember, binomials are expressions where there are two terms. So my next line, there's my root, my square root. There's the 2 that I factored. And now I'm going to try to factor this out and maybe give myself a little bit more so my root covers everything. So I'm going to first focus on the x squared. So I notice the only way that I can handle this one or break it apart would be to do x in each of my groupings, because x times x will give me x squared. The next thing that I want to note here is I want to focus on the 4. Notice that the 4 is positive and so is the middle term. Because of this, we can say that we'll have pluses in each of our binomials. And then we need to figure out, okay, how can I break apart 4 so that when I foil these out, I will get that middle term of 4x. And again, for the sake of time, I'm going to note that I can break 4 into a 2 times 2. We can check to make sure that our work is okay. So again, if we check, we're essentially going to FOIL. So x times x gives me x squared. X times 2 gives me positive 2x. 2 times x gives me a positive 2x. And then 2 times 2 gives me 4. And notice that if I clean this up, I do arrive back at what I originally had in my grouping. Okay, so I'm going to clear that out just because I don't want all of these lines all over the place. So bear with me while I erase this out to clear out my space. Okay, so I'm going to continue to simplify this down. So I have the square root of now 2 times x plus 2, but I can square that. Okay, so I'm just using a shorthand. So the next thing to note, though, is at this point I can break this apart. So again, I can't give each term a square root like I had highlighted up there at the top in red, but if I'm dealing with a multiplication problem, I can go ahead and break each factor apart. So I can have the square root of 2 times the square root of x plus 2 squared. Well, there's really not much that I can do with the first portion, so I will still have that square root of 2, because I only have 1, 2 underneath the root, so nothing can come out. However, notice that I have a square root, and this is being squared, and they will take each other out. So that's going to leave me with an x plus 2 that I can take out of the radical. Here is my solution. So for the next one, note what index you are working with. We're dealing with a 4th root. And again, I would break this into parts. So let's focus on 810. First off, I might say, well, I know that 810 is 81 times 10. Maybe that didn't come to mind. Maybe you decided to divide by 2, or maybe you decided to divide by 5. That all works great. And what I note here is that, well, 81 is 9 times 9, and 9 is 3 times 3. Here are some prime factors, so I'm going to circle those and let them chill out. 10 will be 2 times 5. Each of those are prime factors. Okay. For the next piece, you don't necessarily have to do this, but if it helps, I would encourage it. So x to the 9th, so that's going to give you 9 x's total. Now we can go ahead and start breaking items out. So here's our 4th root. And what I know is I need 4 of the same value in order to take it out. So I'm seeing I have a group of 4 3s. So I'm going to write the 3 on the outside. And actually, before I go any further, I'm just going to draw a line down here so that we can kind of separate what we're looking at here. And the 2 and the 5, they're individual. So I don't have enough in order to break them out, so I'm just going to multiply them back inside. The next thing, let's see how many x's we can take out. I see I have a group of 4 here, and then I have a group of 4 here. So I have x squared on the outside, and then I just have 1 x left over. So there's going to be an x on the inside. And once again, here is our final solution. let's keep going. So the next one, we now have a cubed root of negative 5,000 times x to the 12th times y to the 13th times z squared. Remember that you can posit the argument about the negative, or because you are dealing with an odd index, you can just kick the negative on the outside. So in this case, what I might have here is I'll have my negative out here, followed by my cubed root, with now 5,000 x to the 12th, y to the 13th, z squared. So I'm going to go ahead and focus my attention on the 5,000. 5,000, I can break that into 5 times 1,000. 5 is a prime number. 10,000 is 10, or sorry, 1,000 is 10 times 10 times 10. That's one way that you can start breaking it apart. And each of these 10s becomes a 2 and a 5. So what I want to note here is, again, I still have my negative, and I have 1, 2, 3 5s, so I can take one of those 5s out, and 1, 2, 3 2s. And then underneath that cube root, I still have this 5 here, so that 5 has to stick inside the root. For the next one, you don't necessarily have to sit there and write out how many, or 12 x's and then figure out how many groups of 3. You can just do a division for yourself. If you have 12 x's and I want groups of 3, how many total groups of 3 will you have? And hopefully what you're noting is, well, if I did 12 divided by 3, that's going to give me an x to the 4th. I'll have 4 total groups of 3 that I can pull out, with nothing left over. On the flip side, if we work with 13 and divided it by 3, we would say, well, I can take 4 groups of 3 y's out, but there's going to be 1 y left over. It's kind of like your elementary division problems that you've worked with before. If you do 13 divided by 3, I can put 4 into it with a remainder of 1. The last piece, z squared, well, there's only 2 z's in there, so nothing is going to be able to come out. So I have to leave the z squared where I found it. To finish this out, I'm going to go ahead and combo what I can. So my negative 5 and 2, that'll give me negative 10. My x to the 4th, y to the 4th, cubed root of 5, y, z squared. And this is your final solution. If you have any questions, please let me know, and thank you.